Okay, so here we go. Here's domain and range part 3. So the first two problems are problems you've seen before. Notice problem number 1 is a line segment, it has a beginning and an end. Notice that problem number 2 is a graph that is a ray type graph. Remember, in geometry, we call a ray where it has one endpoint and then it goes on forever and ever and ever in a direction. So you see that has an arrow. So why don't you pause the video and do the domain and range and function for problems 1 and 2, and let's come back and see how you did. Okay, so how'd you do? So notice that we have, for the domain, did you go, the furthest it went was -4, and the furthest to the right was 2. So the farthest it went was to the left was -4 and 2. And notice that we have open circles. So therefore, we should have a compound and for our domain because we have a between, right? All the x values are between -4 and 2. So all the x values are between -4 and 2, and they are less than symbols when you write the between statement. So are you getting your inequality less than symbols written correctly? For the range, it's the highest it went, so it looks like the highest it went was 3, and it looks like the lowest it went was 1. So just to emphasize that, it's pretty much the highest between 1 and 3, and we have the open circles and the open circles because of these open circles. So again, for the range, we have a between statement. So all the y values that are between, the lowest it went was 1 and the highest it went was 3. So remember, this is always the highest, this is always the lowest, this is the furthest to the right, and this is the furthest it went to the left. Okay, on number 2, again, to emphasize, it has an arrow. That means it's going to keep on going and keep on going and never stop. So when we look at the domain, it seems like it starts at 4 and then it just keeps on going to the left, right? So it just keeps on going to the left and it never stops. And we have a solid circle, so this would be solid, and it keeps on going. So we have to write a domain. That's not a compound and statement. It's not a compound or either. It's just a regular inequality. I just see everything that is to the left of 4. So all my x values are to less than or equal to 4, right? Because they're to the left of 4, so they're less than. My y values are as low as -2, but then it just keeps going up from there. It just keeps going up forever and ever and ever. So it starts down here at -2. And then it goes up, and that's a solid circle. So for our range, which are the y values, and remember the y values are what come out of the machine, so we're saying that any number greater than or equal to -2 is coming out of the machine, and remember the x values are what are going into the machine. So our domain and our range, our inputs and our outputs. Let's see what else we have. So notice on number 3 we have a line. A definition of a line is that it keeps on going forever and ever in each direction. So this means it's going to keep on going forever and ever. So if we're looking at the domain, we're looking at the x values, and if it keeps on going in both directions, then basically it's the entire number line because it keeps on going to the right, right? Keeps on going further to the right, and it keeps on going further to the left and further to the left. So it doesn't have a beginning and end. It's just the whole entire. So we can say the x values are all real numbers. And a fancy way of writing all real numbers, we can use set notation. We can use x as an element of the real numbers. So x, this little fancy e, is element of the real numbers. So if you wanted to, you could just write that instead. If you just wanted to write that, or you can write all real numbers, either way. Let's look at the range. The range is how high and low it goes, and notice it doesn't really have a starting and an end, and it just keeps going higher, 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 and it keeps going lower, lower, lower. Let's look at that. So as I go out, doesn't my graph keep getting higher and higher and higher and higher and higher and higher? And at the same time, doesn't it keep getting lower and lower and lower and lower and lower forever? So my y values, or my range, are all real numbers as well. So these are both all real numbers. And if you don't want to write out the words all real numbers, or if you want to start getting used to fancier math notation, then we'd like to see you write this notation to mean all real numbers. So we love when you're using all these extra mathematical symbols. If you think, right, so you get used to it. So when you get into Algebra B next year, you don't feel so weird about seeing some of that fancy notation. And I forgot to do the function. If you drop a vertical line, it hits only once. So therefore, yes, it passes the vertical line test. So yes, it is a function because it passes the vertical line test. It only hit once. Okay, let's look at the other graphs we're going to look at are V's and U-shaped. U-shaped, does anybody know what a U-shape is? Do you remember what those are called? Does anybody happen to know? I don't know if you guys dealt with this, but see, we got some V shapes going on, and we also have some U shapes going on. The U shaped are called parabolas. So let's look at the V. In the V, we want to find the domain. The domain is how far to the left and how far to the right the graph goes. Do you see the graph keeps on going further out to the right? So as I go, it keeps getting further out to the right. Right? Further out to the right, further out to the right, further out to the right, further out to the right. As it keeps going up, it also keeps getting further out to the right as it keeps going up. So as this keeps going up, it keeps getting further out to the right, further out to the right, further out to the right. So what do you think it's going to be? Did you say all real numbers? Yes, it's kind of hard to explain in a distance learning setting. But this one is going to be all real numbers because it keeps going further to the left and further to the right. So the domain is all real numbers. So if you want to, you can write that fancy notation, or you can write all real numbers. And the fancy notation is x such that x is an element of the real numbers. And then for the range, we want to know how low and high it goes. Do you see that it starts here at -3, right? There's the tip of the V, and that's where it starts, and then from there it starts to go up. So it does have a starting location, and then from there it just starts growing up, 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 and keeps going higher and higher and higher and higher, higher and higher and higher. So it keeps on going up, 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 up. So I'm going to emphasize that. And we're going to include what we call the vertex as part of the graph. So basically we have to describe all the y values that are above -3. So all the numbers that are above -3, wouldn't that be y is greater than or equal to -3? And then if you drop a vertical line, no matter where you drop that vertical line, it's only going to hit once. So yes, it's a function because it passes the vertical line test. Okay, so let's see the next one. So do you want to try this next one? Maybe pause the tape. So if we're looking at the domain, notice that it's going down this time, but as it goes down, doesn't it go further to the left, further to the left, further to the left as we go down? It keeps going further to the left, and as we go down, it's going further to the right, further to the right, further to the right, further to the right. So if you said that the domain again was all real numbers, that you were correct. So the domain is all real numbers because it keeps getting further, wider, 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 right? It keeps getting wider. Further, as it goes down, it keeps getting wider, which it keeps going out further to the left and further to the right. So I'm going to use the fancy x. X is an element of the real numbers, and practice using that fancy notation. And then notice the range. The range, it has So the vertex, or the tip, right? That's called the vertex. Notice that's the highest the graph goes. And then from there, it's just going below that. So the V is upside down and it's going below -3 forever and ever and ever and ever and ever, right? And we're going to include the vertex. Because that's not an open circle, that's like a closed circle. So that's going to be closed at -3. So everything below -3 is our range. And don't we write that all the numbers that are less than or equal to -3? And is it a function? Well, if you said yes, you're right, because no matter which vertical line I draw, it will only hit it once. So yes, it is a function because it passes the vertical line test. Here our V is sideways. It's opening to the left. So let's look at the domain. So this time the domain is not all real numbers, because isn't the vertex, so this is called the vertex, where the two lines meet is the vertex. And notice that the x values, this is the furthest to the left it goes. And then from there, it just keeps on going to the left forever and ever and ever and ever and ever. Because doesn't this arrow mean that it's going to keep on going to the left and keep on going to the left forever and ever and ever? So, and then we're going to include the vertex. So the vertex is included. So we have to write a domain that describes everything to the left of 1. So wouldn't that be all the x values less than or equal to 1? Now you see why, when we just got done with inequalities, why we had you practice writing inequality statements so much, because they're used in all kinds of things. And then for the range, notice that when we keep going to the left, it keeps going to getting lower, 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 but at the same time keeps getting higher and higher and higher and higher, and lower and lower and lower and lower. So do you see that the range is going to be all real numbers this time? So the range is going to be all real numbers this time. And if you notice that. So this one's going to be y is an element of the real numbers. Or you can actually write all real numbers. And then when we do a vertical line test, doesn't it hit in 2 locations? So if it hits in more than 1, then it's not a function. So it's not a function because it fails the vertical line test. It hit more than 1 time, so it's not a function. And here 7, 8, and 9 are just like the V's, and the same idea as the V's, except for they're just a U-shaped instead of 2 rays pointed together. So it doesn't have a point, it has a nice soft curve, and those are called parabolas. And so you might want to stop and do 7, 8, and 9 yourself and see if you can figure them out by looking at the V's above it. Okay, let's see how you did. So for the U's, or the parabolas, don't we see that as this goes up, it's going to get wider and wider? You can barely tell, but it's going to get wider and wider and wider and wider. So all of these points are going to be used. So as it's growing and getting higher and higher and higher, it's also getting wider, wider, wider. So that means it is also the x values to the left and to the right keep going. So there is no, it doesn't stop to the left and it doesn't stop to the right. It keeps going. So this one's going to be x is an element of the real numbers, right? Isn't that a lot faster than writing all real numbers? And then remember, the range is how high and how low does it go. And notice that it has a low point. So the lowest it goes, that's also called a vertex. The lowest it goes is -4. And then from there, it just keeps rising and getting higher and higher and higher and higher forever, right? And we know it's forever because that's what these arrows mean. So that means it's going to keep getting higher and higher and higher and higher. So we have to write the range is everything above -4. So we should write all the y values that are greater than or equal to -4. And then if you drop vertical lines, it will pass. So yes, it is a function. Number 8. So number 8, as this time it's dropping. So it starts up at 2 and then it keeps on dropping and getting lower, lower, lower. But once again, as it gets lower, it gradually is going to get a little bit wider. So it never stops going to the left or to the right. So it gradually keeps spreading out further to the left and further to the right. So again, it's all real numbers for the domain. And then what about the range? So the domain is X is an element of the real numbers for the domain. And then the range isn't the highest it goes is 2, and then doesn't from there, doesn't it just get lower, 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 lower forever and ever and ever? I'm going to put that in black just so you can see it a little bit better, right? Because it keeps on going, because the arrows say it keeps on going. So we have to describe everything that's below 2. So everything that's below 2 would be the range. So don't we write all the y values that are less than 2? If you're talking about numbers less than, that would be numbers that are below. Okay, number 9. We'll blow this one up. Okay, so do you think the domain is all real numbers? Do you think the domain is all real numbers again? So if you said the domain is all real numbers, you would be saying that the graph is everywhere. The graph is everywhere. And I don't see the graph over here at all. I only see the graph in this part. So I don't see the graph over here at all. I only see the parabola. The sideways parabola is only from here on. Right? It's only from this part on. So the parabola is not all real numbers. My eraser doesn't want to work. So it's not all real numbers because it does have a start. So notice that the vertex, this is called the vertex, this little point at the bottom, so it starts at -2 and then it keeps on going to the right forever and ever and ever because there's arrows here. So we have to describe the domain has to be everything that is to the right of -2. And so wouldn't that be all x values greater than or equal to -2, because we're also including the vertex. So we're including the vertex in that. And then the range, doesn't it keep going higher and higher and higher and higher and lower and lower and lower and lower? So the range is going to be all real numbers. So the range is going to be all real numbers. So y, don't forget to say y when you're talking about the range, use the correct variable, is an element of the real numbers. And then is it a function, yes or no? Does it pass the vertical line test? Does it hit it only once, or does it hit it more than once? And it hits it more than once, so therefore did you say it's not a function? Because it failed vertical line test. It hit it more than one time. Okay, so that's part 3. So hopefully you're getting really good at domain and range of pictures. Domain and range of pictures. Watch your inequality symbols and make sure that you're getting your inequality symbols right. You can take a cell phone shot of this, and you can also see your notes. There's a page of notes up in the module. Have a nice day.